faster than light travel, time travel. It's always the stuff of pure science fiction, isn't it?
Well, yeah. Mostly because we run into that huge wall. The paradox.
Exactly. The classic go back in time, accidentally prevent your own birth, and poof, universe implodes. Or something like that. It just feels like a fundamental no-go zone.
Right. Our whole sense of cause and effect just rebels against it. The logic seems, well, broken.
Okay, but what if? What if there's a loophole? We're going to dive into a really fresh theoretical paper today. It's proposing a way to maybe have both FTL and time travel without those paradoxes blowing everything up.
And the approach is pretty radical. It's not just playing with the 4 dimensions we know. They're actually adding another one.
That's the core idea. The paper's called 5D Time Cycle Geometry, a paradox-free framework for FTL and time traversal. It's by Jeremy Baker, just out on the preprints.
Very recent, then.
Yeah. So our mission today is to really unpack this 5D geometry idea. How does it claim to let us, break the light barrier or loop in time without causing causal chaos?
And we have to keep an eye on those usual challenges, right? The paradoxes, obviously, but also the enormous energy people usually say you'd need.
Definitely. Okay, so let's start with the basics. This 5th dimension, what is it in this model?
So the fundamental concept is taking our normal space-time, the 3 spatial dimensions plus time, and, well, extending it, adding a 5th dimension. The author calls it W.
W. Okay.
Now, it's important to grasp that this isn't just like another direction you can point in. The paper frames it more like a time container.
A time container. Okay, that sounds cool. What did that actually mean?
Well, think about our usual space-time. Now, imagine this 5th dimension, W, existing alongside it, but specifically providing a sort of playground, a domain where time itself can behave differently.
Differently how?
It's proposed as a place where closed time-like curves, CTCs, the paths for time travel can actually exist. But the key is they exist mainly within this 5D space, this container.
So they're sort of cordoned off from our regular 4D reality.
That's the idea. It's a pretty big conceptual shift. It's not just adding space, it's adding a new layer for how time can work.
So the time travel could happen, theoretically, in 5D, but it wouldn't necessarily spill over and create, say, the grandfather paradox in our world.
That's exactly the argument. And what makes this possible, what drives it, is something the paper calls a dynamic cycle function.
Right, I saw that. The math cal CW, the W, looks like some math is involved. What's its job in this 5D picture?
Okay, so this function, think of it like a rhythm or a wave propagating along that 5th dimension, W.
Yeah.
It actively modulates or changes the space-time geometry and how fields behave as you move along W. The paper has a figure X, showing this visually how it affects energy density.
So it's not a static extra dimension, it's dynamic. It pulses maybe, hence the sine waves.
Exactly, it's cycling. And that dynamic quality is apparently crucial for enabling these warp drive-like solutions the paper talks about.
Warp drives. Okay, now we're talking. We know the Alcubierre drive concept, warping space-time. But the killer has always been needing that exotic matter, the negative energy.
Right, the seemingly impossible stuff.
So how does this 5D setup potentially help with that problem?
Well, the cycle function, mathgalc, is key here too. The paper argues that the way this function interacts with the 5D space-time metric, the rules for distance and time there naturally leads to solutions that look a lot like warp drives.
Naturally, without needing mountains of negative energy.
Potentially with less need for it, or perhaps accessing it differently. There's another figure Z, that shows how the cycle function could modulate the warp bubble's potential speed depending on where you are in W and in time.
So this whole 5D structure, with its cycling function, might be the key to making warp drives seem less fantastical by tackling that energy barrier.
That's definitely one of the implications the paper puts forward. It's trying to address that major roadblock.
Okay, and you mentioned time loops before. The CTCs, the paper says they can exist in 5D. Figure A shows a visualization.
Yes, it does allow for them within the 5D geometry.
Right, but then paradox alarm bells start ringing immediately, don't they? How does the theory stop those logical contradictions?
Okay, this is the crucial part. The claim is that while these CTCs exist in the 5D bulk, that higher dimensional space, they were confined there.
Confined.
Yes. When you project these paths down onto our familiar 4D spacetime, they don't form the kind of loops that lead to paradoxes in our experienced reality. The 5th dimension essentially acts as a buffer zone.
A buffer zone. like a safe space for time loops.
Yeah.
They can happen in 5D without breaking the cause and effect rules we live by in 4D.
That's a good way to put it. A safe space. It keeps the temporal shenanigans contained, so to speak.
Okay, now let's circle back to the negative energy for warp drives. You said this 5D geometry might reduce the need for it. How exactly?
Right. So figure X, the one showing the cycle function's effect, it also illustrates how this function influences the energy density landscape in 5D. And it shows that there can be localized regions where the energy density driven by this cycle function actually dips into the negative.
Ah, so the negative energy is generated within the 5D structure itself.
Potentially, yes. The paper suggests that the specific geometry, maybe combined with ideas from string theory, could allow these localized negative energy patches generated by math calc to be harnessed. This might lower the overall amount of exotic energy you'd need compared to standard warp drive models.
Interesting. So 5D isn't just for time loops. It might also be a source, or at least a facilitator, for the energy needed for FTL.
It seems to be a mechanism where the 5D geometry and the cycle function work together to potentially ease those very extreme energy demands that have always plagued warp drive concepts.
This really does stretch the brain.
Yeah.
The paper also has these other visualizations you mentioned. Can we walk through what they show?
Sure. Figure B looks at time dilation. It's just there's a constant rate of time dilation caused by this 5D setup, by the cycle function's influence.
Constant time dilation, meaning time would just tick at a different rate if you were in this 5D reality compared to us.
That seems to be the implication, yeah. A fundamental shift in time flow.
Okay. What else?
Then there are the geodesics, the paths particles would follow. Figure C gives a simplified view, just looking at the time in fifth dimension plane. It shows this kind of surfing motion along W.
Surfing.
Yeah, like movement in our normal space is coupled with movement along W. Figures Y and D give more complex 3D views of these paths over time. They suggest motion through 5D could look like quite unusual trajectories in our normal 3D space.
So our everyday movement might have this hidden fifth-dimensional component we're completely unaware of. Wild. What about forces and fields?
Good question. Figure E shows a quantum field snapshot illustrating how its shape or distribution is affected by the cycle function in 5D.
So the field itself is modulated.
Exactly. And then there's a whole series, figures F1 to F20. These show the field evolving dynamically over time and at different points along W because of the cycle function. It's like watching the field breathe or pulse with the 5D rhythm.
Wow. So the fifth dimension isn't passive. It actively shapes space-time and the stuff within it. Okay, back to the big one, causality. How does this whole framework really claim to solve the paradox issue definitively?
The absolute key is the confinement, keeping those closed time-like curves, the time loops, contained within the 5D bulk.
Right, the buffer zone idea.
Exactly. By ensuring they don't fully manifest as causal loops in our 4D spacetime, the theory aims to preserve the normal sequence of cause and effect that we observe. The fifth dimension handles the temporal weirdness, leaving our 4D reality causally consistent.
A separate layer for temporal tricks, that does make it conceptually easier to grasp.
Yeah.
But look, for any theory like this to be taken seriously, it can't just be math, right? It needs predictions, testable ones.
Absolutely critical. And the paper does lay out three main predictions. Figure D, showing the trajectory, also hints at these scales.
Okay, what are they?
First, it predicts TV scale Kaluza-Klein modes. These are basically heavier echoes of known particles that you'd expect if there's a compact extra dimension.
Like the extra dimensions in string theory predict.
Similar idea, yes. And TAVI scale means they might just be within reach of particle colliders like the LHC or maybe the next generation of colliders. We could potentially see evidence of W.
Wow. Okay, that's concrete. What's prediction number 2?
Second, it predicts tiny variations in the fine structure constant alpha, like really tiny changes around 1 part in 1020.
1 part in 10 to the 20. How can we ever measure that?
With incredibly precise atomic clocks, it's pushing the limits of measurement, but it's potentially detectable. It would be a very subtle fingerprint of this 5D cycling.
Amazing. And the third prediction?
High-frequency gravitational waves, but with unique features tied to this 5D cycle function. The dynamic spacetime should ripple, creating these waves.
Detectable how? LEGO.
Maybe not LEGO, which targets lower frequencies. The paper suggests pulsar timing arrays might be sensitive to this kind of high-frequency signal, using pulsars as a galactic detector network.
Okay, so signatures in particle physics, fundamental constants, and gravitational waves.
Yeah.
That's a proper scientific theory, isn't it? It gives us ways to try and break it or confirm it.
Precisely. That's what elevates it beyond pure speculation. And the author also notes it seems compatible with some string theory ideas, specifically certain compactifications.
String theory again, always lurking nearby in these discussions. So where does the research go next, according to the paper?
Two main things mentioned are trying to quantize the cycle function itself, apply quantum rules to it, and simulating 5D black holes within this specific geometry.
Bringing quantum mechanics into the picture and seeing how black holes behave in 5D. Sounds challenging.
Definitely. Those simulations could reveal a lot about gravity in this higher dimensional context.
So this paper isn't the final word, it's more like opening a door.
Exactly. It's laying out a new framework, proposing these concepts, and critically offering those testable predictions for the community to explore, refine, or, challenge.
Okay, let's try and wrap this up. Key takeaways from this deep dive into 5D time cycle geometry.
Well, the core idea is this 5D spacetime where W, the fifth dimension, acts as a kind of time container. This potentially allows for FTL via warp-like effects and time travel via CTCs, but critically, it aims to avoid 4D paradoxes by confining those CTCs to the 5D bulk.
And the engine for this is the dynamic cycle function, mathcal W, which modulates spacetime and fields, and just might, reduce the need for that pesky negative energy.
Right. And crucially, it makes predictions, things we can actually look for.
Yeah, those predictions really ground it. The Kaluza-Klein particles, the tiny alpha variations, the specific gravitational waves. Those are the keys to seeing if this is more than just elegant math.
Absolutely. It gives experimentalists and observers clear targets.
This whole discussion really makes you wonder, could our familiar 4D universe just be like one slice of a much bigger, weirder, multi-dimensional reality?
It's a profound thought, isn't it? Maybe time and space are woven together in ways far more complex than we currently perceive. If you start thinking about higher dimensions seriously, what other connections, what other physics might be hiding just beyond our view? It certainly fuels the imagination about what secrets the universe still holds.